Hello everybody! In this lesson I will discuss typical questions that you can expect in the exam on the Theorem of Pythagoras. Question 1. Given EF is equal to 5 centimeters and EH is equal to 13 centimeters. If G is equal to GH, and you can see it's indicated on the sketch there. Calculate the length of GH and FG. Now, when you go to the triangle, you can see that it's a right angle triangle since the angle at F is a right angle. And then we know we can use the theorem of Pythagoras to work out the length of FH, and then we will cut it in half since FG is equal to GH. So let's start. In triangle EFH, we can say hypotenuse squared is equal to one side squared plus the other side squared. Hypotenuse is EH squared is equal to EF squared plus FH squared. And the reason? Pythagoras. Now we can substitute in EH's place. 13 squared equals EF is 5 squared plus FH squared. 13 squared on this side means 13 times 13, which is 169, equals, and 5 squared is 5 times 5, 25, plus FH squared. 25 walks across, 169 minus 25 is FH squared, 144 is equal to FH squared. Then we want only FH, we take the square root both sides, and we end with FH is equal to 12 centimeters. So that means the whole length there, this whole length from there up to there is 12 centimeters. Therefore we can say if G is given that it's equal to GH, so we can divide FH in half. Therefore, FG is 6 centimeters as well as GH, also 6 centimeters. Question 2. Calculate the following. Number 1. The size of X. So X in this case is in fact side BC. So what we have is we have two right angled triangles. We have triangle ABC, and then at the bottom we find triangle BDC. And this is where we will start. We will start with this one, triangle BDC, and work out the length of BC, which is in fact X. Since BDC is a right angle triangle, we can use the theorem of Pythagoras. So we will start by saying hypotenuse squared is equal to one side squared plus the other side squared. So for that triangle, it will be BC squared equals BD squared plus DC squared. Now we can substitute. Oh, remember to add Pythagoras. BC squared equals BD was given that it's 16, so 16 squared, plus DC is given that it was 12, 12 squared. 16 squared on this side will be 16 times 16, which is 256, plus 12 squared is 12 times 12, which is 144. 256 plus 144 is equal to 400, and then we can take the square root both sides, and we end with BC is equal to 20. In other words, X is equal to 20 centimeters. Before we continue, have you subscribed yet? Or you can like this video, and better yet, please tell your friends about my channel. Let's continue. Still on question 2, the second part is now they want us to calculate the size of angle BAC, which is this angle over there. Now, from the previous slide, we calculated x's length was 20. In other words, BC's length is 20. So, AC's length is also 20. So, can you see that triangle ABC is indeed an isosceles triangle with these two base angles equal? Then, furthermore, to calculate the size of A, we can work with the theorem that interior angles of a triangle are supplementary. So I want to show you here that, remember, maths is integrated with all the theorems and all the work that we've dealt with so far. So you cannot just see it in isolation and think every sum has to be the theorem of Pythagoras. You can now also incorporate all your other work. So we will start by saying that in triangle ABC, although it's a right angle triangle, we can say that angle A plus angle B plus angle C is equal to 180 degrees, and the reason, angles of a triangle. Then we know that angle C is 90 degrees. That's where the right angle is. So the 90 degrees can walk across, we subtract, and we end with angle A plus B is equal to 90 degrees. But we know that angle A is equal to angle B since BC is 20 and AC is 20, and the reason we will use is angles opposite equal sides. Both sides are 20. Then, in the place of B, now we can substitute that one with an A. So we end with A plus A is 90 degrees. A plus A is 2A is 90 degrees. Divide away the 2. Therefore, angle A is 45 degrees, which is what they wanted. Angle BAC is 45 degrees. Question 3. Determine the length of AB correct to 1 decimal place. Now, when you go to the sketch, can you see that there's this right angle triangle, the big one, ACD, and then there's also another smaller right angle triangle, BCD. So we are looking for the length of AB. So what we will do is we will use the big right angle triangle ACD, and we will calculate the length of AC. And then we will move over to little triangle BCD, and we will work out the length of BC. And then to get to AB, we will subtract AC minus BC. So let's start. So it's a right angle triangle. So we can say in right angle triangle ACD, the big one. The theorem of Pythagoras says hypotenuse squared AD squared is equal to AC squared plus CD squared. Then Pythag said that. We can substitute. AD is 18 squared equals AC squared, that's what we want, plus CD was given 7 squared. 18 squared means 18 times 18, which is 324, equals AC squared plus 7 squared is 49. Let the 49 walk across. 324 minus 49 is 275, equals AC squared. So we'll take the square root both sides, and we end with AC is 16,6. So this whole length is 16,6. Now we can move over to little triangle BCD. It's also a right angle triangle. So we can use the theorem of Pythagoras. Hypotenuse squared, which is BD squared, is equal to BC squared plus CD squared, Pythag. Now we substitute. BD is 15 squared equals BC squared, that's what we're looking for, plus CD was 7 squared. 15 squared means 15 times 15, 225 equals BC squared plus 7 squared is 49. 225 minus 49 is BC squared. 176 is equal to BC squared. Take the square root both sides. Therefore, BC is equal to 13,3. This little tiny one there, 13,3. So to find the length of AB, we can say AB is equal to the whole of AC minus BC. 16,6 minus 13,3. Therefore, AB's length is 3,3 units. Thank you for watching my videos. Remember, I prepared the whole syllabus for you. And do me a favor, please tell all your friends about my channel, Online Maths by Miss Pythagoras. Goodbye.